Hello students! By the end of this video, you should be able to classify a function as one-to-one. The reason we're going to do this is it helps you figure out whether or not a function has an inverse function. In order to do this, we're going to start by just graphing the two functions I've given you here. I'm telling you f of x is an example of one-to-one. G of x is an example of something that's not one-to-one. We are going to use this visual to develop the definition of one-to-one. So I'm going to pause the video and graph those. I want you to do the same thing as well. Okay, so our red function is our one-to-one function. Our blue function is our not one-to-one function. Before we discuss this, I'm going to have you do one more thing. This is a practice of the last video, but I want you to graph F inverse and G inverse using what you already know. So again, please pause the video and do that on your own. It's a good way to test yourself. Okay, I've graphed the inverses. I've done this in two ways, so if you did it in either way, you can check your work. The first method I chose was to take my table of values from my original functions and switch the x and the y. So an original point on f was 0, 5, so f inverse is 5, 0. Same thing with g. Okay, the other option is you can solve for the equation of the inverse function. So again, switch your inputs and your outputs, or your x's and y's, and solve for y. So I get my equation for my inverse functions as y equals x minus 5 over 3, and y equals plus or minus the square root of x minus 4, which will give you the red equation and the blue equation here. Okay, color-coded it so you can match which one goes together. The point of doing all this is to figure out what is a one-to-one function and why do I care what a one-to-one function is. So I'm going to go back to my objective actually. At some point we should be able to classify what a one-to-one function is, but the other part is you should be able to interpret this to justify whether or not the function has an inverse that is a function. If I break this down, we can develop the definition here. And this is what I want to focus on. So if you know a function is one-to-one, you can tell whether or not the function has an inverse function that is a function. Okay, so that's kind of hard to think about here, but remember, something's not a function if it fails the vertical line test. So if you look at the inverses here, which one is a function and which one is not? Okay, so my blue line is a function because if I draw vertical lines everywhere, it'll only cross through the blue once. Whereas my red function, or g of x here, fails the vertical line test because at that line here, it's going to cross twice. It's going to cross once here and once here. Okay, so f is a function, or f inverse is a function, but g inverse is not a function. So therefore, our original g, it might have an inverse, but it's not an inverse function because it fails a vertical line test. Now to put this together, we said f is one-to-one, and what we just learned is that its inverse is a function. So it has an inverse, and its inverse is also a function. G of x is not one-to-one, so its inverse is not a function. So in conclusion, the reason we figure out if a function is one-to-one or not is because one-to-one functions always have inverse functions. Whereas if it's not one-to-one, the inverse may not be a function. Inverse is not a function. Okay, so again, this is the why we study one-to-one functions. Now I'm going to go back and define what a one-to-one function is. Okay, so a one-to-one function, and I've got a bunch of different definitions here. One's a good one from the internet, and one is from your book. So I'm actually going to start with the book one, because we need to learn to use our books a little bit this semester. So this is taken straight from your book. You can go back to your book and look at this. These little boxes are usually pretty informative. So I've given you this whole printout, but I'm going to highlight what I think is the most important part here, or the easiest to understand. And that's this statement here, which comes in the second part. So what it says is if a function is one-to-one, then yada, 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 but if f of a equals f of b, then a equals b. So what this says is if the outputs, so remember these are kind of like your y's, so if your outputs are the same, then your inputs have to be the same. Okay, so these are kind of like your x's. So let's go back to the picture to figure out what this means exactly. That's why we graph these up here. Okay, so if you take a look at the function that's not one-to-one, if I take 2 points, say these 2 points, so if I take f of 1, that equals, let's see, that's 5. But if I take f of negative 1, that's also equal to 5, which makes this an even function if you think back to last semester. Okay, the reason that this is not one-to-one is because if our outputs are the same, a one-to-one function would also have to have the inputs being the same. So this would only be a one-to-one function if f of 1 was the only thing that outputted a 5. Okay, but since 2 different things output 5, then this is not one-to-one. So in order to determine if a function is one-to-one, we can do something called the horizontal line test. And if it crosses through more than once, then it's not one-to-one. Whereas the blue line will pass the horizontal test everywhere. So for example, if I take this point here on the blue line, let's see, that's f of negative 1 equals 2. Okay, there's no other point on the blue line that will also have an output of 2. Okay, so this blue line here will pass the horizontal line test. Everywhere I draw a horizontal line, it will only cross through once. So you should have in your notes, horizontal line test. I'm going to let you write that definition in your own words. Okay, another definition I thought was helpful back when I was in college, actually, is this little visual right here. So one-to-one function in college, sometimes they call it an injective function, but we'll call it one-to-one for this class. The definition is that each input, so every x value, has its own unique output. So every x value only has one output. And this is the visual it needs to have to be injective or one-to-one. Okay, so if A are the inputs and B are the outputs, every input only maps to one output. So like the blue one goes to the yellow one here, but it doesn't go anywhere else. Okay, this blue one only goes to this yellow. And it's okay that there is an output that doesn't have an input, but you can't have an x value going to more than one y value. So there's lots of different ways to think about this definition. You can think about it graphically, you can use this little mapping, you can just use the definition. But the reason, again, we do this is because this will tell us a lot about the original function. So if a function is one-to-one, then its inverse is a function. That's what I said on the front side. All this other stuff is pretty self-explanatory from things we've talked about with inverse functions and whatnot. Okay, the last thing I want to mention and just kind of make sure you're aware of is this function here. So if you take the inverse, you have to include the plus or minus, and that gives you this sideways parabolic shape, which is the inverse of a parabola, which makes sense because we talked about the inverse function being a reflection over the origin. So this would kind of flip over that line and give you a sideways parabola. Now, oftentimes when you see this square root function, you'll see the parent function is y equals the square root of x, okay, not y equals plus or minus the square root of x. Okay, the reason this is the parent function of the square root function is because this is a function, whereas if you include the plus or minus, it's not a function. Okay, so the reason people do that is to force it to be a function, but what they're really doing is restricting the range. So what that means is they're forcing all the y values to be greater than 0. So instead of including the minus on the outside, which would make us have y values that are negative, we're saying our y values can only be positive by only doing the positive square root of x, which would then look like this red function here. By doing that, this passes the vertical line test. Okay, so this would be a function. So if you're wondering how could I force the inverse be a function, or why do I see it like this, or any of those kinds of questions, this is why that's the parent function. And if I ask for something to be a function, you shouldn't include the plus or minus. Okay, if that doesn't make sense, please come to class with questions. In general, write down any questions you had throughout the video, and I will see you later. Have a good night.